Yes, class. Am I audible? Good evening.
Good evening, ma'am. Good evening.
So, Donna, Priya, Reem, Wafia. All right.
Yes.
Donna, yes, you had texted me for the papers also. I think just 2 papers were left, right? And I only get time to check the papers on Friday. So on this Friday, or not, I'll not delay it for Friday. Tomorrow I'll try to check it, Donna. All right, just
Okay, ma'am,
two
no
papers are left. Okay. So today also you have your test, so that also I'll check it and submit your both the scores together. Even I wanted to share the scores, but couldn't get time, and 2 papers are left only. So that's why it is just keep on getting stuck. Let's complete with refraction class now. So refraction basically, Donna, you're saying something?
I was trying to say that it's okay. I thought I
Okay,
didn't know
okay.
how the tests work
Yes.
because this is the first
Yes,
time.
yes, yes, yes. Because I had also written it on the group that whoever have not received their scores, just text me. No, that was for the other batch. Okay,
Ma'am,
okay.
also
Donna.
I'm not in the group.
You're not added on the group. Okay,
No,
that's
ma'am.
why you send it. Okay, okay, okay. I'll get you added because I'll share the scores on the group only. I'll get you added. If someone else is
Okay.
also not there, let me know. I'll get you added on the group, Donna. Okay, okay, Rifat. Fine. Now, C class, refraction. So basically what all things are there? Again, reminding. You have reflection of light completed. We are going to start with refraction. This is very important. Then you have optical instruments. This will take 2 classes. 1.5 classes enough for this topic. Basically, you need 2.5 hours around. So I think for this batch, we need classes. 2 classes will be enough. And one topic you have prism. Today we'll start with this. This is the lengthiest topic of the lesson. Once this is done, your chapter will be quite stable. Last year reflection was deleted. This year it has been added. So again, I'm repeating, pay attention to that. Now, few very, very basic properties that I didn't discuss in reflection, and I had told you that I'll discuss it over here. Rectilinear propagation of light. Rectilinear propagation of light simply means that light travels in a straight line. This is what is meant by rectilinear propagation of light. We see, if a ray of light is coming from the tube light, if I'm able to observe that ray of light is coming, so what happens here? When that ray of light comes, that ray of light does not bend anywhere. Bending of light is a different phenomena that we'll study later on. But in general, without any exception, you have what the light traveling in a complete straight line. There are no edges, there are no turnings of light rays, at least. Even the sun, that's why we are able to see objects. If, for example, let's say there's a wall, why am I not able to see things behind the wall? If a wall is there, I'll be only able to see that wall. Why will I not be able to see the things that are behind that wall? So reason is this only because the rays into my eyes will not go like this behind the wall. Firstly behind the wall, then coming into my eyes like this. No, light rays have to travel in a straight line. Even if a source of lamp light, any source is kept behind the wall, that will travel in a straight line through the wall. And if it's an opaque wall, that will not allow the light to transmit. So that's why I'm not able to see the object. Had it been a transparent, then it would have allowed the light to pass through it. But it will never happen that the rays of light, if this is the wall and this is the source, rays are coming like this, like this, like this, and this. No, light has to travel in a straight line. And this property is known as rectilinear propagation of light. Separately, nobody is going to ask you this part, but for the basics, you have to understand. Principle of reversibility is important. The way you had any ray of light that was passing through the center of curvature, what happened? It retraced its path exactly. That is principle of reversibility only. For example, let's say I have kept certain mirror and this is placed at this angle. Now what is happening? Ray of light is incident. So according to the laws of reflection, it will get reflected. Here also, according to laws of reflection, it got reflected. But here it is making exactly an angle of 90 degrees. So what will happen? If there is no angle, the angle of reflection is also 90 now. An angle of incidence is also 90 now in this case. So what happens? The ray retraces its path exactly with which it had covered. Till here it will go. This principle is known as principle of reversibility. So this is also written here that this principle states that if the final path of ray of light after it has suffered several reflections and refractions is reversed, instead of keeping this like this, it is now kept at such an angle that 90 degrees made, means 0 degrees made with the normal, 90 degree with the surface and 0 degree with the normal. So once it retraces, it will retrace the path exactly in the manner with which it arrived. All right, that is known as principle of reversibility. Now, object is what? Object and image we are continuously using. So what is meant by an object? Object is basically a source of light. Now, you can have luminous objects. You can have non-luminous objects. See, luminous object means an object that emits its own light. For example, if I talk about this tube light which is kept on this wall. So that tube light is a luminous object. It is producing its own light, right? But I am able to see the laptop. I'm able to see the screen of the laptop. I'm able to see this. So what's the reason? This is not emitting its own light. Why am I able to see this? Because the light rays from the luminous object is striking this non-luminous substance, that is this laptop, and then these rays are reflecting back in my eyes and images formed on retina, and I'm able to see this. So this laptop, it didn't produce any ray of its own, right? Any light of its own. So we classify this as non-luminous. Luminous objects are bulb, light rays, lamp, tube lights, all these sources of light. Sun is a luminous source of light which produces its light, that is a luminous. But in nature we are able to see different types of lights as well, different types of objects as well. It is not just that I'm able to see this tube light, I'm able to see this laptop, I'm able to see this pen. What is happening? Right, light ray from the luminous object is striking this non-luminous object, and these rays are entering into my eyes and through my lens, firstly through my specs, then after the specs through the convex lens that is present within my eye, then through the convex lens into the retina, optic nerve is taking it, cerebral cortex is forming the image, and so on and so forth. Like this, the image is formed. Fine. Like this image is formed. About eye, I'll discuss it with you when we'll do optical instruments. Before that, I'm not discussing eye, and human eye is not in your syllabus as well. So this is the difference between luminous and non-luminous objects. That's why we say objects are any source of light. Whenever we say, if I keep this pen also in front of the mirror, this is also an object. It's not necessary that it has to produce a light of its own. Light can be produced by the natural source of light as well. Now, objects, this is luminous and non-luminous, but objects can be real object as well and virtual object as well. Real object means when you actually have an object over here. You actually have an object. So what happens? Like this has a physical existence. This is a physical entity. This has a physical existence. So this is a real object, right? So all the rays are diverging for real object. Always remember this. This can be asked to you in your theoretical 1 mark or 2 mark or short answer questions you have. There you can be asked to write these facts. So these are basically diverging rays. And then comes the group when you have a virtual object. Virtual object you can understand in this way. When an object is not actually there, but it is acting as an object, you can see, let's say I have a concave mirror here. Fine. Some light rays have striked it, and here an image has been formed. Now what do I do? Some image, let's say because of cross section, image has been formed here. Now I keep a convex lens as well. Here I am keeping a convex lens. Now what is happening? Whatever was the earlier object, I'm not concerned with. Now this image that has been formed, this is the final image. This is emitting light sources, and now rays are getting refracted and reflected, and finally I'm getting a final image. So what happened? This image of the concave mirror acted as an object for the convex mirror. There was no object present. Object was the initial object only which produced this image. This intermediate image produced the final image. So this final image that has been formed, this is because of an object which is actually not present. This is not a physical real object. It's an image that has been formed. So such kinds of objects are known as virtual objects. Virtual objects you can understand by, or if the image is formed behind the mirror, then also that virtual image will become virtual object like this. So real object, and also you have to remember, if you know in that you have a virtual object, so rays of the virtual object will be converging. They'll converge at a point. That you will see through ray diagrams only if you observe and analyze certain ray diagrams. But no need to do that. If it comes in your exam, directly write the statement. And this will come in your application-based questions only. If a real object is kept, then what happens to the rays? What is the nature of ray? So nature of rays are basically diverging rays. Like this, you have to write it. So image is what? If this was object, wherever rays meet, or even if they are appearing to meet at a point, even if you extend it and they are appearing to meet at a point, they are appearing to meet at a point. As in here only, this example which I was telling you over here, what had happened? Even we have completed mirror, what did we see? One ray of light passed through the focus, other passed through the center of curvature. So this point the rays were meeting, right? And one case, remember we did when the image was, when the object was kept between the focus and the pole. What happened? There the light rays traveled like this. So what did we do? The rays didn't meet. We extended it and saw where the image appeared to meet. So this image is known as virtual image. This is from behind the mirror. This is actually not the rays and were not meeting. The rays were actually not meeting. We had extended it to know where the image could form. So such kinds of images are known as virtual images. And the image that is actually formed by the intersection, no, there is actual intersection, those are real images. When the rays that pass through the center of curvature, through the optical center, you will see in case of lens, or through the focus for both lens and mirror, they actually intersect. That point where we mark the image, that is a real image. But when we extend it, produce a dotted image because the rays are actually not meeting, that means they are appearing to meet at some point. So that is the real image. So these are the basics for your lens as well as for reflection also that we have discussed. We have to start with refraction. But before we start with refraction, just write down these initial points of introduction. From here right now. So prepared with EM waves? Subjective test will be there. Class questions are from two topics. One question is from the properties of EM waves part that I told you, E is equal to E naught sine omega t plus minus kx. That equation, B is equal to B naught sine kx plus minus omega t. These two questions are there, and other questions are from electromagnetic spectrum. Yes, Priya. Sorry, reflection only. EM waves, you already had your test. EM waves test. So last test was EM waves only. No reflection test you have to do. Yes. Reflection test is there. Now see, the next topic is refractive index. Refractive index, no, you have mathematical definition for it perfectly for writing in your exam. Ratio of this quantity, ratio of that quantity, that you can easily write, that I'll tell you. Before that, no, refractive index is actually what? See, for example, you have some material. We have some material, let's say copper. We have copper is a material. Copper has a certain density that will tell about the material. Similarly, if I take brass, it will be having its own density of brass, and that density will determine the other properties of it. Similarly, now just focus on ray optics, only on optics, specifically this ray optics part. Whatever is the optical density of any glass, of any medium, let's say two types of convex lens are there. So both the lenses will be having different optical density. See, material is glass, that I agree, that because this is not the normal density. This is not mass by volume density. That is the optical density. Optical density means this is density of the glass, that will determine how much a ray of light can be absorbed, how much a ray of light can be reflected, how much amount of the ray of light can be refracted. That optical density for all the different substances. These are for all the different mirrors you have. Mirrors you have, or lenses you have, convex lens, concave lens, and not only convex lens and concave lens differences. Within convex lens also, lenses of different aperture, lenses of different focal length, lenses of different optical center. Fine, we'll do lens, so I'll tell you the structure and everything in detail, but before that, just have an idea of it. So that difference in all the lenses, that is known as refractive index in reality. Now, what it is mathematically, I have already written it here. Here you can look. Absolute refractive index exists and a relative refractive index. When we are comparing the density, optical density of the glass with respect to air, fine. Medium, when one medium, let's say, to air or vacuum, that is absolute. But when you are making a comparison of two different media, two different, oil and water, air and water, different, not air and water, oil and water is best, is better than this. So these are two different media. That case you have, in that case you have relative refractive index. Now, formula of refractive index is basically ratio of two speeds, ratio of two wavelengths. When light, see, light will always travel from one medium to another medium. If light travels within the same medium, so you can see light is traveling within the same medium only, air. Is anything happening? No phenomena is occurring. But let's take the example through the glass. Right now, what happens? Ray of light strikes. When it is striking, rays are striking the lenses that are present within the glass. So what will happen? When the rays will strike within the glass, refraction is occurring. One phenomena occurs. So glass and air, two different media, right? They are two different media. So speeds in two different media. Let's about the medium, we'll discuss it later. But just understand, refraction will only occur, refraction of light, that is bending of light, that will only occur when two medium are present, two different media are present. So ratio of their speed or ratio of their wavelength is basically refractive index. If you take the ratio of air with respect to the other medium, two, what did I say? Two velocities are there, ratio of two velocities or ratio of two wavelengths. If one velocity is air, then it becomes absolute refractive index. If both the velocities are different apart from air, other than air, then that is known as relative refractive index. Fine, so that has been written, the refractive index of a medium of a light of a given wavelength, same thing. Till here. So see, in short, it is, yes, it is represented by N or the symbol mu. So in certain books you will find this symbol mu, in certain books you will find n. I prefer n because mu is used in other places also, no, permeability and all that, so it become confusing. Somewhere I'll also use mu, but both have the same meaning. Both of these denote the refractive index only. So refractive index with these symbol is basically ratio of speed of light in air, and speed of light in air we know that is 3 into 10 to the power 8. Speed of light in air is fixed, 3 into 10 to the power 8 meter per second. This is fixed. But speed in some other medium we are not aware of. Wavelength of light in air, no need, we don't have a specific value, but in air is one medium, and this medium can be some other medium. Fine. Coming to relative refractive index, this is refractive index of medium 1 with respect to medium 2. It means your one medium will be some V1 and this will be V2. This will be equal to lambda 1 by lambda 2. Now, what is V1? V1 is speed of light in medium 1. Similarly, V2, you can analyze speed of light in medium 2. Lambda is 1 is wavelength in medium 1. Lambda 2 is wavelength in medium 2. Here you are not talking about air. Now one representation before we move on to the question answer. One representation. If I write n, let's say refractive index in the second medium by refractive index of the first medium. If I write this as n21, this means refractive index of second medium with respect to the first medium. If I write n12, that means refractive index of first medium with respect to the second medium. That is a way of writing when you take the ratios of two refractive indices. N2 by N1 is N21, refractive index of second medium with respect to the first one. Fine. Refractive index of first medium with respect to the second one, N1 by N2. Like this. Fine. Clear or not till here? First tell me, all of you. Clear? Yes, no, any queries? Yes, Donna, Priya, Rifat.
Ma'am,
Yes, Vafia.
ma'am, so in absolute refractive index, one medium will be air only.
Yes, that is fixed. Air is fixed. So especially when it comes to in some questions, if you find it, you are thinking data is missing, something is not given. In the question, no, absolute medium or air will be mentioned. So try to use the speed formula because you already know the speed. So from here, one variable will not be unknown to you. This will be known to you, that is speed of light. So absolute one medium will definitely remain air. That will be fixed. One medium will be air and speed of light in air also we are aware of. So try to use this formula rather than wavelength if you are able to use speed. All right, one medium will remain air. Any other doubt, Wafia?
No, ma'am.
Okay. So note it down, class, then we'll do numericals on this. Is it clear to you, Aman? Aman, Madiha, clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, let's discuss this question, class. A light of wavelength 6000 angstrom in air enters a medium with refractive index 1.5. What will be the frequency and wavelength of light in that medium? Ray of light, a light of wavelength 6000 angstrom enters in air. So absolute or relative refractive index is given. What is this 1.5?
Absolute.
Absolute, because here this medium is air. So absolute refractive index is given as 1.5. Yes, Maria, correct. Absolute. So frequency and wavelength we have to find out in that medium. See, refractive index is 1.5. Wavelength is already given to you, 6000 angstrom, or you can write it as 6 into 10 to the power minus 3. Not minus 3, sorry, 6 into 10 to the power minus 10. 6000 into 10 to the power minus 10 meters. This is the wavelength. So 6 into 10 to the power minus 7, no, we can write it as. What all things speed of light we already know. That is not mentioned, but speed of light in one medium we know because that medium is air. Right. Anything else? No, I think this. Now see, when light travels from air to the refracting medium, its frequency remains unchanged. What will be the frequency? Frequency will remain unchanged. All right. From air to the refracting medium, the frequency remains unchanged. So, but what is that value of frequency? That we can calculate, no? So, if you have speed, if you have wavelength, see, speed is always equal to wavelength multiplied by frequency. The symbol is frequency, nu. Correct. Perfect answer, Madhya. Exactly this answer. So, if you have speed of light as c, this is wavelength, this is frequency, you will get the frequency as frequency will be equal to speed of light by wavelength. Wavelength, angstrom, no? Yes, Maria. Correct. Angstrom you've kept. This is right. So frequency will be what? Frequency will be 3 into 10 to the power 8 meter per second by wavelength, that is 6 into 10 to the power minus 7. So this becomes, Madhya has already answered it correctly, 5 into 10 to the power 14 hertz. This is the answer. So this is the frequency. In both the medium, frequency will remain the same. Remember this fact as a theoretical fact also. Frequency remains unchanged. All right, then now you can calculate. See, refractive index is the given. Refractive index in air is given. This is lambda, not lambda. We have to calculate. So refractive index n, refractive index, which is, this is 1.5, is refractive index in air by refractive index in that medium. So in that medium, it will be refractive index in air by wavelength in air by refractive index. So lambda in this is some medium. So wavelength in this medium will be wavelength in air. Wavelength in air is 6 into 10 to the power minus 7 by refractive index, which is 1.5. So again, this was answered by Madiha. Answer will be 4000 angstrom. All right, note down this question. One last question we'll do before you start with your test. Madiha, did you receive your answer sheets of the exam? Half yearlies? So if you've received it, let me know what's your score. Others also, please let me know what all scores you have obtained in your half yearlies. Okay, the last question. Refractive index of glass is 1.5, refractive index of water. Refractive index of glass is 1.5, refractive index of water is 1.3. Speed of light in water is 2.25 into 10 to the power 8 meter per second. Velocity in glass is unknown. C class. If we talk about refractive index of glass with respect to air, that is given to us. This is absolute refractive index given for glass, and this is absolute refractive index given for water. But now we'll be calculating the relative refractive index. No, two media are involved, glass and water. So see, refractive index of glass by refractive index of water. That is refractive index of glass by refractive index of water, or we can use the relative refractive index formula also. See, absolute refractive index is given for Ng. Not talking about water, just Ng. This is absolute, no, for the glass. So this will be speed of light divided by speed in glass, and speed refractive index of water will be speed of light by velocity in water. Now take the ratios. Ng by Nw, that will be C by Vg into Vw by C. Cc gets cancelled, so Ng by Nw is equal to Vw by Vg. From here, Vg will be equal to Nw by Ng into Vw. So velocity in glass will be 1.3 by 1.5 into 2.25 into 10 to the power 8 meter per second. So when you will solve this, I think the answer should be around 1.95 into 10 to the power 8 meter per second. Just check it once. I remember this answer, so I have written it directly. Just cross check if this is right. All right, quickly write it down and text me done. Then we'll start with the reflection test. Test is small, reflection test is very small. Apart from Madiha and Priya, all those who have completed, just text 2 minutes more so that we can start with the test. I think nobody is writing now. If anyone is writing, just let me know. Because maximum students and Rafat, you can take at least have the paper with you. Do have the question paper with you. Ray optics. So 3 questions. One is this derivation, 2 numericals. All right, class, start with it. Rafat, after taking the screenshot, you may leave. It's better if you all can open your video cameras for the test. And from the next test, it is compulsory. I think I had already announced that now onwards, you all have to open up your cameras. Others also, please try if it's possible. Only Priya Darshini has made an effort. So from the next test, all of you have to open your cameras. This time only Priyadarshini, Aman and Dona made the effort to open up. Okay, Priya, I have received your sheet. Priya, you can leave. Thank you so much. Amin, Wafia, Madiha, hurry up.